Okay, so last thing, we're going to have a rectangle with a point A at 7, 5. So we're going to put point A here at 7, 5. All right. So draw up three other points of the rectangle. We have point B can go anywhere. So I'm going to put point B at 9, 0 right here. Okay. Point B is going to be here at 9, 0. All right. Now, there's AB. We should be able to calculate the slope of AB. Okay. And also use that rise and a run to get the distance of AB. So slope is 1, 2, 3, 4, 5 over 2. So slope of AB is negative 5 over 2. Again, I put a negative here because it goes down from left to right. Now, if we have a rectangle, ladies and gentlemen, just draw it off to the side here. Okay, we know all of our angles are 90 degrees. So if we're trying to go from point B to plot a point C out here, okay, we need to have some kind of line. Well, 90 degrees, okay, means we have a perpendicular line, okay, perpendicular line. So I need a perpendicular slope for BC from negative 5 over 2, okay. So the perpendicular slope from BC from negative 5 over 2, okay, we flip it, change the sign, positive 2 over 5, okay. So any multiple of positive 2 over 5 we can use as our slope. So 4 over 10, 6 over 15, 8 over 20. Any of these multiples would work. For the sake of varying it up, I'm going to do a slope of 4 over 10. And again, you can use either one of these, okay? But I'm going to go 4 over 10. So I'm going to go down by 4, 1, 2, 3, 4, and over by 10. So should be a 1, negative 4 right there. That'll be our point C. You should see we have a nice right angle right there, okay? So parallel lines, so AB, we need a line that's parallel to AB up here. So DC is going to have the same slope as AB, which is negative 5 over 2, okay? So we'll go up by 5 to the left by 2 to put our points D. Okay? Then we connect D and A, and again, DA should have the same slope as CB. So if I go up 1, 2, 3, 4, and over 3, 6, 9, 10, there we go. Okay, so next we got all of our points. Okay, so next we want to do our diagonals to find point E. Again, same thing we did with the parallelogram. Okay, point E, okay, is going to be the midpoint of the diagonals. Okay, so midpoint of AC or DB. Okay, next, find the lengths of the sides. Okay, so the lengths of the sides, again, all we really got to find is AB and BC, because AB and DC are equal to each other, and AD and BC are equal to each other. Okay, so again, we can go to the distance formula calculator for that. So we have point A is at 7, 5, and point B is at 9, 0. So if we go to the distance formula, okay, so we just go 7, 5, 9, 0, calculate the distance, 5.39 units, so we'll call that 5.4. Okay, so from A to B, we can call that 5.4. BC is 5.4. Okay, BC, so we have 9, 0, and then 1, negative 4. So we got 9, 0, or negative 1. Is it negative 1? Negative 1, negative 4, excuse me. Calculate that. Distance of that is 10.77, so we'll call that 10.8. Okay, so the distance from B to C, 10.8, and that's 10.8. Okay, again, what we can do now is we can find the length of the diagonals here. We have a right triangle. 5.4 is one side. Okay, 10.8 the other. So we could do a little Pythagorean theorem to find the length of that diagonal from A to C. Same thing would happen from D to B. And again, we could do a little inverse trig